Hey there, AP Environmental Geoscience students. Are you ready to get hit with some knowledge, some math knowledge? All right, buckle up because here we go. I'd like to talk about energy and power, show you some conversions and dimensional analysis, and go through a few examples with you so you can be successful. I'm not going to ask you to memorize these conversions, but they'll be provided to you for you on any kind of assessment. Just refer back to these at any given time. Now, to start this conversation, let's talk about this very simple triangle where P is for power, E is for energy, and T is for time. And the unit that power is in, we're going to start with now, that is watts, but that might change depending on how you have to convert it. Energy is, we'll start with joules. Now, that might be converted to kilojoules or whatever the question's asking you, but let's just start with joules. And time is over here, and time is in seconds. Now, you can use this triangle to solve for the unknown. Power is equal to energy divided by time. Energy is equal to power times time. And time is equal to energy divided by power. And we'll come back to this little triangle in the near future. So our first equation that you need to know is power is equal to volts times amps. So remember, power, eventually we're going to get into, the unit is going to be into watts. So volts times amps is equal to a watt. An example problem would be the current through a vacuum cleaner is 8 amps and the voltage is 100 volts. So this question is fairly simple. It's asking find the power in watts needed to run this vacuum cleaner. I highly recommend in any math problem that is a word problem that you write out the unknowns or you write out the variables and then you solve for the unknown. In this case, it's fairly simple. We need to solve for P. Power is equal to 100 times 8, and power is 100 watts, which again, I go back to this triangle right here. So that's an example on how to find power using volts times amps. Now, when we look at this triangle and we find the watt, the power is equal to joules over time or joules over second. Now, that means that if you have 100 watts, that's the same thing as saying 100 joules per second. If you have 1,000 watts, that's the same thing as saying 1,000 joules per second. 50 watts is equal to, yep, you guessed it, 50 joules per second. So that is a really important concept to grasp for our next practice problem. Our second example, let's just say a 100-watt light bulb has a life expectancy of 800 hours. How many kilojoules, and I underlined kilojoules so you know what unit that the question is asking you to put your answer in. Now, the conversion rate here is 1 kilojoule is equal to 1,000 joules. So how many kilojoules is needed to run this light bulb for the full life expectancy? Now, I already pre-wrote the answer to save time in this video, but you need to start with what you know. We know that the light bulb is 100 watts, and that is the same thing as saying 100 joules per second. So start here, 100 joules per second. And remember, I highly recommend that you write the units out and then attach a number to it so you know what cancels out. For example, if you know 100 joules per second, then you know seconds has to go up here on the numerator to cancel that seconds out here on the denominator. Well, there are 60 seconds in 1 minute, and then 60 minutes an hour, and the minutes cancel. The problem told you that for every bulb, it lasts 800 hours, so hours cancel. And now, by the way, if you want to attach just bulb, because that's 800 hours per bulb, if you're confused about what unit goes here. So my hours cancel each other out, and the question's asking you to put your answer into kilojoules. So even though that this joule is all the way over to the right, it still cancels this joule out. It's just that joule has to be on the denominator. That's why, oh, well, you might be confused. Where do you put these numbers, on top or on the bottom? Well, that's why you got to start off with the unit first. I know that joules has to go on the bottom, which means 1,000 has to go on the bottom because that joule cancels this joule out. And when you multiply across and divide by 1,000, the only unit left standing is kilojoule. And that should be a really good sign because that's what the question's asking you. And the answer is 288,000 kilojoules. Now, you could do this one of two ways. And let's just, right here, it asks a 100-watt light bulb, and it asks you to convert that information to kilojoules. That's what your answer should be. This question, however, is a little bit different. It's asking you to convert your answer to kilowatt hours. So I did it one of two ways. Well, I mean, I did it both ways, but I wanted to show you both ways. Every day, Mr. Belak uses 600 watts total to run one TV, one computer, a hair dryer because he has some pretty snazzy hair, and he has this electric hand lotion warmer. For all of those appliances, total up 12 and a half hours per day, every day. The question's asking, how much electricity does Mr. Belak consume each year? And put your answer in kilowatt hours when operating the appliances above. So here are some conversions that you need to know. So again, I pre-wrote the answer to save time with this video. You start off with what you know, and you know that he uses a total of 600 watts, which is equal to 600 joules per second. Seconds cancel, minutes cancel, hours cancel, because he uses all that in a total of 12.5 hours per day. Now this is for the whole year, so the days cancel. There are 365 days in a year. And right here, it told you that there are 1 kilowatt hour in 3.6 times 10 to the 6 joules. I know that this number has to go on the denominator because that joule has to cancel that joule out. Multiply across, divide by 3.6 times 10 to the 6, and this is how many kilowatt hours that Mr. Belak uses in a year to operate those appliances. But you can do it an easier way, and the way that you figure out, I only say it's easier because it's less steps. And if you have less steps, that means that there's less chance of making a mistake. So you start off with what you know. We know that it's 600 watts, and you write that down. We also know that 1 kilowatt is equal to 1,000 watts. So my watts go on the denominator because that cancels that watt out. So 1,000 goes on the denominator, and it's equal to 1 kilowatt. We know that he uses these things for 12.5 hours per day for 365 days in a year. So my days cancel. Well, what is a kilowatt times an hour? Because you have to multiply everything across on the numerator, but don't forget to multiply the units. I mean, if there are 2 units that aren't canceled out, you have to multiply a kilowatt by an hour. And you guessed it, a kilowatt times an hour is a kilowatt hour. Oh my! So the only unit left standing in the denominator is years, and my unit is exactly what the question's asking, kilowatt hours per year. And look, I got the same exact answer, and I did it a different way. I just skipped 2 or 3 steps. Now, this slide is just going to explain to you how I knew to use the easier way. And it all boils down to this. This question is asking for kilojoules, so it doesn't make sense to start with watts because you have to go through joules and convert it to kilojoules. But this question is asking for your answer being kilowatt hours. You might as well just skip all that joule stuff and go straight to kilowatt hours, or just use watts, I should say. So instead of doing it this way, do it this way. Start with 600 watts, 1,000 watts in a kilowatt, 12.5 hours of operation per day, every day for the whole year. Days cancel. A kilowatt times an hour is a kilowatt hour. And the only unit left standing over here is a year. So I know that I'm pretty much doing this problem right because that's what the question's asking me to put my answer in. So when to use and when not to use the 1 watts is equal to 1 joule per second, it all depends what the question's asking you to put your answer in. Again, this is kilojoules. It's some form of joule. And this is kilowatt hours over here. So do it the easier way if you can. Skip this step. The more steps that you use, the more chance you're going to make a mistake. All right. Well, I don't have much more time in this video, but my follow-up video will then pick up the other couple examples that I have for you. All right. Hope you learned something. Bye-bye.